Oh, us humans, we always meddle in everything, don't we? We think we know the world just because we've traveled to a few places, but the truth is, we know very little. The depths of the sea, for example, hold countless mysteries, and there are even statistics to back it up. According to the Convention on Biological Diversity, 80% of the ocean remains unexplored, and 91% of marine species have yet to be identified. Amidst this vast unknown, one can't help but wonder what lives at the bottom of the Mariana Trench, the deepest part of the ocean. It doesn't seem like one of the nicest places to live, though. The nearly 11,000 meters of depth mean that light barely reaches there, and finding food is quite challenging. If you think you know what it's like to live under pressure, you've probably never ventured into this place. According to scientists, the deepest point in the ocean has such an immense pressure that it would be like supporting the weight of a small car on the tip of your thumbnail. Despite all these challenging conditions, there are creatures that inhabit this space, such as sea cucumbers, crustaceans, and even some eerie-looking fish, like the black devilfish. The first dive to the bottom of the Mariana Trench took place in 1960, conducted by U.S. Navy Lieutenant Don Walsh and Swiss engineer Jacques Picard. They embarked on their journey in a specially designed exploration submersible named Trieste, a bathyscaphe-type submarine that lacks propulsion and is supported by a military ship called the USS Wandang. The Trieste began its descent into the depths of the Mariana Trench around 8:15 a.m. on January 23, 1960. By 9:20 a.m., it had reached about 1,000 meters in depth, entering near total darkness. At 11:30 a.m., Jacques and Don had reached an astonishing depth of 8,200 meters. At this point, they released some ballast to slow down their descent and avoid crashing into the seafloor. Even though they encountered numerous challenges, including loss of contact with the surface, they pressed on. The pressure at this depth was so extreme that it was akin to sustaining the weight of a compact car on a fingernail. Their remarkable journey continued, and at noon, they hit the seafloor, stirring up a massive cloud of dust. To explore the deepest part of the ocean, they turned on the submersible's lights and began their investigation. At 1:06 p.m., Jacques and Don were astonished to discover life at this depth. They identified a flatfish surviving 8 kilometers away from sunlight and under pressures 1,000 times greater than at the surface. Their groundbreaking exploration came to an end at 1:26 p.m. on January 23, 1960, when they released the ballast, and the Trieste began its ascent back to the surface, a journey that would take 4 hours in total. The submersible spent about 20 minutes submerged in the trench. The Trieste was retired in 1963, but its achievement remains relevant to this day. Despite technological advancements that have made remotely operated robotic probes more practical for deep-sea exploration, the feat of Jacques and Don endures. Interestingly, their discoveries piqued NASA's interest in underwater expeditions, despite their space exploration focus. The U.S. Space Agency, NASA, has been conducting expeditions of this kind, primarily in the Mariana Trench. NASA's goal is to leverage the experience gained from these ocean missions to study the natural satellites Europa of Jupiter and Encelado of Saturn. Currently, it is known that the surface of Europa is composed mainly of water ice, and its thickness can vary from 15 to 25 kilometers. Beneath this icy crust, there might be a subsurface ocean that could potentially support life. Following the principle that where there's water, there's the potential for life, much like the discovery of species 11 kilometers below the surface of the Pacific Ocean, it's highly likely that there could be living organisms in the depths of Europa. According to astrobiologists at the American Space Agency, the moon Europa could harbor similar conditions to Earth's oceanic trenches, with the existence of something akin to hydrothermal vents, emitting fluids and gases that could provide a habitat for various life forms. Furthermore, it's also suggested that Encelado, one of Saturn's 82 natural satellites, might contain conditions suitable for life. In 2005, the Cassini spacecraft made several flybys of Encelado, coming close enough to reveal details about its surface and environment. In particular, the probe discovered a water-rich plume in the polar region. This finding, along with evidence of internal heat and a scarcity of impact craters in that area, suggests that Enceladus is geologically active. Additionally, periodic eruptions of water vapor from the Moon's interior, breaking through the icy surface to reach astonishing altitudes, have been observed. In 2018, Cassini also confirmed that these vapors contain water, indicating the presence of a liquid ocean beneath all that ice. However, to make these expeditions thousands of miles away and at such great depths possible, NASA has been conducting various tests right here on Earth since 2008. In addition to tests with remotely operated submersibles like Nereus, NASA's Jet Propulsion Laboratory, JPL, has been using data from other explorations, cross-referencing them with their own studies. This not only involves examining the engineering of the equipment but also studying the life forms found, as they may provide insights into the potential coexistence of extraterrestrial life. If there are animals here on Earth that can survive at such incredible depths and under immense pressures, it is plausible that places in outer space, where the existence of frozen oceans covering liquid water has been confirmed, could harbor scientifically significant life forms with incalculable value to science. Nonetheless, many more tests and studies will be required before NASA can consider the possibility of exploring worlds beyond our own. There's no better place to start than our own Earth's oceans, which still hold many secrets. Until next time.